Hello, thanks for having us. My name is Victor Moreno. I'm a distinguished TME with the enterprise networking side of the house at Cisco. And with me, I have my colleague, Mike Herbert, who is on the data center side of the operation. Mike, you want to share with us some of the things that you've worked
Sure. Again,
Victor over the years?
Yeah, I apologize, Victor. Victor and I played the Bobbsey twins on these topics for a long time. We've worked together forever. Again, we're bringing the two sides of the business. I'm his peer from a technical perspective, focused on Nexus, ACI, Tetration, previously UCS. And so how all does this stuff fit together? And we sort of have been working with core engineering teams to bring all the products together in a usable sense, right?
Right. And from my end, I've been focusing lately on access networks, campus integrated wired and wireless, software-defined wide area networks, and so forth. Right. So what we wanted to talk to you about today is how do we actually bring this together as far as integration, horizontal integration, where we actually bring common elements and align common elements across the data center and the access network. But we also wanted to emphasize the importance, as we do this, of the vertical integration in each and every pocket of the network that you will find along the path between the user and the application. Right? Some of the relevant topics include macro segmentation in the form of VRFs or bridge domains, and basically network-driven segmentation, but also micro segmentation in terms of access control policy. And more important, we want to emphasize service levels and how we actually do path optimization based on those policies, right? And how do we actually bring that picture end to end? And what are the type of vertical integrations that play a role in achieving a successful horizontal end-to-end experience, right? So always think, as we're talking through this, there is a line that cuts across, but there's all sorts of vertical integrations along the path to make that happen, right? One of the key vertical integrations that need to happen is in the areas of identity and authentication, right? This is not a trivial problem, and it's very different on the data center side versus the access side, right? So there's very specialized operations that need to happen in these areas. So we'll share with you what we do there in the data center and what we do there in the access network. And as we said, it's all about horizontal and vertical domain integration, and that's basically going to be our topic. So one of the key things that we've been trying to do to simplify the rhetoric around this whole very complicated topic is basically going back to basics. So what is it that we're trying to do? We're trying to basically get those endpoints, those users, those light bulbs, all those phones, all to connect to their applications, right? And what we're going to be discussing today is an application provider environment that is indeed a multi-cloud environment. You heard a lot about ACI Anywhere in the previous session. Well, basically, how do we actually get a common model by which we can articulate exactly what we intend to see happen as we connect users or things that may be connecting in a multitude of ways to applications that may be offered from a multitude of different data center incarnations. So getting that to a normalized view is the key to simplifying this. And it's not necessarily a matter of just having a single domain or a single controller or anything of that nature. It's a matter of actually having a model that allows us to actually do this in a normalized way, right? So we will see as we go from the data center, where we're doing all sorts of really interesting things to build our applications, that we offer those and we make them available to our access networks through a multitude of entry points. Right? And that is basically, you could think of the edge between the data center and the access network as a logically centralized function, but it is really physically distributed, right? You're going to have in multi-cloud a series of entry points, and we basically leverage our wide area technology to get you to those different entry points in a normalized manner. Okay? As you can see here, I'm cutting across a series of domains. I go all the way from my access network that is specialized in consolidating wired and wireless access, in the future maybe even bringing 5G into the picture, identifying users, identifying things, light bulbs, profiling all of these different endpoints, and then handing you over to a domain that is specialized in optimizing how you actually cut across a multitude of service providers, the internet, combine all of this, measure your performance, react based on that measured performance, etc. So very specialized activities happen in that WAN, and then we get to a distributed footprint that needs to integrate very tightly with the data center. Now, do we want to have a different model for each different cloud provider that we have out there? The idea is to try and normalize that, right? So that's where something like ACI and ACI Anywhere come in, and Mike will talk more to you about that. So what we're suggesting we do is that we normalize the model and how we articulate the relationships between those users and endpoints and the applications, right? So if you think of it as basically the relationship between a series of user groups and a series of application groups, basically what we're trying to do is just state, well, if I have user group X and I want that to talk to application Y, I'm going to define a contract that governs the relationship between these. If you think of the access control part of the house, well, a simple contract or an analogy to a contract may be just how you define an access control list. Right? You define who is the source, who is the destination, and then between those, do you allow or do you deny? In that articulation of how you actually access things, you may specify further, well, I am going to allow a particular type of traffic. So you may say group X talking to application Y, allow only traffic that is HTTP traffic, for example. Right? That's a very simple example of what this could look like. Now, this could get more sophisticated, where I actually look at application types, DSCP values, etc., qualify things further, and then it's not just about permit, deny, but I can actually copy traffic, I can replicate traffic, I can define what kind of service level I want to apply to this traffic. Right? Now I'm normalizing the way I articulate my intent, and this is foundational to this whole notion of intent-based networks, and I'm normalizing it into a very simple construct of source, destination, and a contract in between.
Okay, have to ask this question.
Please
Whenever the marketers talk about us about intent-based networking, it's this magic thing that will magically transform the business intent into whatever networking terms. Yep. What you're saying here is very pragmatic.
Yes.
Let's take the sources and the destinations and what we have to do, and let's call that our intent. Mm-hmm. So there's a huge gap between their unicorn intent and your practical intent.
Well, so this is basically the grammar behind the intent that they are articulating up in the keynote room. So there isn't that much of a disconnect if you really start peeling the onion back. Simply put, what I'm trying to do, again, back to the first diagram that we showed, is articulate how I want the user to talk to the application. We live for the application, right? That's why we build a network. You would never get on your computer, well, maybe you get on your computer to look at a spreadsheet that's local to the computer, but for the most part, you get on computers these days to actually connect to an application that's somewhere in a data center. Right? So we're going over that network. So all we're trying to do is articulate how I get from users to apps. Now, if this sounds pragmatic to you, then I'm encouraged, because the idea is to actually bring it down to reality. And what is the intent? Allow these users to talk to the application they should talk to, and do that with gold service, for example. So I'm not saying this port or this interface over BGP, put a VLAN on it. Not all of that may be happening, but what we're really saying is just user X to application Y, give it preferential service, and off you go. That's your articulation. Right? So that's the intent. And for that to actually happen, right, we need to first and foremost get or simmer down the endless number of endpoints that we have on either side, both on the data center side as far as application endpoints goes, and on the access side as far as users and things go, into a finite number of groups. Right? And so that's the identity portion of this whole thing. So once we've identified, we can then go ahead and author these relationships. Now, I'm going to have different concerns in different portions of the network. Particularly, there's a difference between the access domain and the data center domain. In the access domain, I have to integrate with wireless. I have to look at recognizing devices that I don't control. I have to allow access for bring your own devices. I have a series of concerns that are very different from the integration with Kubernetes and all the analytics that I run in the data center, all the large-scale integration, and so forth. In either case, I am actually identifying endpoints, but I'm doing it in very different ways. So it makes sense to have dedicated controllers in either side. So whether these are the same breed of controllers or not is secondary, but the key thing is that these things are basically customized and tailor-built for their task in their individual domains. And the same thing applies to the security domain, and you could argue that for the wide area network, you do want a dedicated machine that is actually focused on doing what it's doing. They could all be based on a similar software architecture, but they will be different controllers, right? So one of the things that we face often is basically the question about why do you have these different controllers? And I think the key is, how do you integrate those controllers? And the way we do it is we basically provide a common view of what the intent is and have these different controllers be able to interpret this and interpret it in a way that is meaningful in their different domains. Right? So for me to actually select a gold service within a switched infrastructure, that might be irrelevant because everything tends to be gold when you have multiples of 100 gig interface. But as I go into the WAN, that might be very relevant. Likewise, in the WAN, I might not be enforcing access control, but I might be doing that in my data center and my access network. Right? So I provide basically a single view of what the intent is and have that be interpreted in the different places. Again, to get to the intent, the first thing I do is I identify my endpoints, I group them, and once I have them grouped, then I can go ahead and apply policy. One example of policy is segmentation, where I can have broad segmentation in terms of virtual networks, or I can have more granular segmentation in terms of access control rules between groups. The problem of the identification, not a trivial problem. So just to give you an example, in the access network, I have basically to interact with my Active Directory, my multi-factor authentication engines. I have to look at compliance, health of the devices, etc. I am triangulating also with ongoing services that are always looking at what are the new threats that are out there, what are the traffic patterns that I have out there. I'm always looking for compliance to, is it safe to actually bring this thing on board, right? So not a trivial problem. So we have dedicated engines that actually deal with this and reach out to the different services and triangulate all of this, right? Now, that's not unique to the access network. In the data center network, we have a similar scenario, right? And Mike's going to share with you the type of things that we do in the data center.
Right. So conceptually, what we're doing in both places is the same. We're trying to identify what's there, and the two questions are, what level of granularity do we want, and what mechanism? What's the authoritative source to say something is what it is? In user space, it is based almost entirely for people on user login, right? You know, you get an ID in Active Directory, or there's some framework in which people are authenticated. So there's a notion of a trusted device and a trusted person. When we get into the compute space, how do you know that that VM is what it says it is? We use a different set of tools, the industry does. It uses the workload managers. Kubernetes identifies what something is. vCenter identifies what something is. If you're in Amazon, it's the configuration tool. So the labels that come associated with the creation of the workload may be the technical piece that we leverage, and Andy was talking about that in the previous session. But the idea is these various workload managers are the authoritative source for something can connect, what is something, and why, and should it be there, right? So that's similar but different. The only other thing that we think matters, am I coming up fast enough?
I'll go.
Oh, okay. Yep. Sorry, I apologize. There was an animation there. The other piece that we think is different is, from a classical perspective, a device that a user is using may be running multiple processes and functions on it, but it is a device that's authenticated to that user. I mean, we can talk about multi-user terminals, in the old days, but essentially that laptop is your laptop, and everything you do on it, even if you have 300, 400 processes, are yours. So the authorization, the identity for all those processes can be bundled together. When we get into a workload environment, we have a different degree of sharing. So the granularity of identity that needs to exist inside the compute space or the application space, we believe is more granular. Hence tools like Tetration, we're actually discovering process identity. So when we start thinking about this user to app model, it's not user to server, it's user to process, because from a code perspective, that's a more granular model for us to actually build that user to app edge vertice on and features and functions you want to apply to it, because that JVM is different from that JVM that may be running on the same large cluster server complex. So again, we want to include the identity sources that go beyond the device that the workload runs on. Right? And when we get into pure containers, we get back to a device-centric, because one process equals one IP address and one logical device. But in the spectrum or heterogeneous space, we need this type of identity added to the device identity framework. Make sense so far? So that's why, again, from a perspective, we've got different points of integration with the identity sources and the identity pieces into the controller, which then start to federate data across the two of them. Right? Click through the animations. Right? The other piece that we're very focused on this is when we look at the rationale behind doing this, the rationale is to improve the velocity of business, right? Reduce the friction in changes required from a business perspective against IT. Everything we're talking about is IT functionality, right? But from a business perspective, and again, I phrase it this way, and you may agree or disagree, there's really essentially three types of changes that the business drives relative to IT. The one most of us focus on is I need a new access point, I need more bandwidth, I need some change done on infrastructure, an access list, firewall change, something else. What the business process is more correlated to is our hire, fire, promote an employee. The line of business suddenly says, you're a manager now, which I've given you an access to a set of managerial tools. So you've got Active Directory, some other authentication source. The other aspect is that I'm developing a new code, a new app, so the development structure, whether it's DevOps or AppOps, I group them together into one logical group. They want to make their changes because they're offering a service that is then going to be consumed. Those are the two changes that we believe are closer to the business change. Right? So rather than driving infrastructure as the change that bubbles up, we're trying to actually get those changes, again, developer, ACI, frameworks, all the tool set down, user authentication, all the frameworks coming down. So those two changes can actually be driven into this infrastructure, which does the enforcement, it does the policy, it does the service level, and it does the monitoring of all of those pieces. Again, does that seem reasonable, you guys? So we're trying to do two things. It's not just this, but it's also how do we fit this way in terms of the business processes better. Okay? So from an implementation perspective, this is actually starting to happen. We've been doing this for a while, and we both were laughing about how long we've been doing this, but it's finally starting to happen. We are shipping today Campus SDA fabric, ACI fabrics, which, when you put the two of them together, actually provide for identity federation across the two domains. So when we create user groups in DNA, which is creating groups in ICE underneath, those groups are communicated to the data center infrastructure, the APIC infrastructure, and we get equivalent group creation in this controller domain. So if I create a new branch manager group, that branch manager group appears over here as an external, we call it inside the data center, external EPG. Similarly, when we create groups here, they are cross-populated onto the other side. Now there's obviously controls. Do you want to have all data center application components exposed to the user space? But there's controls on it. But the basic premise is, first, the groups are federated, they're the same. And the second piece is when we actually look at mapping of individual endpoints or things to groups, that's also shared and exchanged across. So user logs in, .1x login, I actually find I'm a branch manager, I put it in a group. That information is communicated over here. So this side of the domain is aware of the mapping of endpoint to group. Group creation and group membership is dynamically updated across the two domains. What that
Sorry, one question. What mechanism do you use to synchronize these two?
Today, the mechanism, and we're going to go talk about where we're going, but the mechanism today is using the RESTful interfaces between the two systems. So again, both systems effectively give you an API that you could use from any tool to do this work. And so we're just cross-populating the two APIs. I have a call to basically create an EPG. There's a call to create an SGT. There's a call to notify that there's a new endpoint in a group. And so we're using that today.
Is there a middleware that is doing both API calls and then vice versa, or do the two controllers talk directly to each other?
Right, and again, it's a good question. Today, it's a pairwise integration. Phase 1 or phase 0.1, however you want to think about it, is a pairwise integration to do two things. Get this out, because people have been asking for it, and to validate all of the second stage use cases and operational questions that people want out of it. So today, it's a pairwise integration. Okay. What we're asking for and what we're working on is, and we'll get to, is actually a bus model with multiple publishers and subscribers. And that's actually coming very soon, but this is actually already shipped, right? This was effectively available ACI 3.2.1 and later, ICE 2.4, patch level 5, ICE 2.5 and everything later. All of this works in is TAC scale tested to support the number of users that we support in an SDA campus, connected to the number of endpoints or applications we connect into an ACI data center. So that's what exists prior to 2019, right?
But it was in one-to-one combination, or you were already able to stitch multiple controllers together?
So we can do multiple pairwise,
okay.
But again, it's still pairwise today.
Pairwise.
And I know but that's not the end state, but it's an introductory state to get something real and working, to validate this is what you think we want to do, and you have customers actually say, I have a solution to the problem I've been asking for a long time now.
Yeah, it's fair.
Right.
Sure.
In the end, somehow you have to implement those contracts. So yes, the ICE is reporting that these users belong to this security group, and the APIC is taking that in, but in the end, it has to be translated into echoes.
Or some function.
Yeah, exactly.
So
and that's my question.
Right. So this is important. So we want to make sure we finish, because where we are right now is federation of identity across the domains. Federation of policy, which is what you're talking about, is what we're working on and what's coming next, right? So what we have now is identity federation. So I still have to create the contract with the rule set over here for whatever you do. I still have to create the SGACLs over here.
That's okay.
Right.
But in the end, that contract on APIC has to intake the users on the other end somehow, and has to push the policy down to echoes in the top of rack switches.
Correct.
So how to identify the users on the other end? Is it by IP addresses, or is it something smarter?
So today, the identity of the user when they log in is driven by the authentication process. And in this network, we're carrying the class ID, or the label, the 16-bit label that identifies that specific group. Okay. We have the same label implemented over here. It's the same, the packet formats between these two, except for a couple of bits for some diagnostic information here, are identical. So the same class ID is present on both sides. So today, and so phase 1, what we're doing is we're basically, class ID comes across, we then communicate this IP address is in this class, and we do a second classification. Phase 1, or more like 0.1, has some functional holes in it. The first hole is that the data plane is not contiguous yet. The data plane will be contiguous, which means that label gets passed through
so you
later this
are
year.
Today doing label remapping.
Label remapping today, right?
But it is not IP address lookup.
So today, the label remapping at the two sides depends on whatever you're doing at each of the sides. The simplest case is you use a /32/128 label lookup, IP lookup, to redo classification. That's the simplest case that we have today. That
doesn't scale, but yeah.
Again, right now it's scaled, so the number of users we support here, it scales to support that. And it works, in other words...
Okay, so what's the number of users?
25,000 is what an SDA Fabric supports today.
Okay, that's fine. That scales.
The interfaces have been tested and support up to 64,000. Hardware that hardware that we've got today will actually support 256, but we're really scale testing towards what the two sides both agree is their maximum scale. If I do 2 here and 7 here, we test at 2. Right? So that's what's happening today. This connection, the data plane will be replaced with a label-based data plane that carries the class ID, so there's no more reclassification. Now it's label, either you trust label or it's a service provider label-to-label swap. So now the label set's much smaller than the IP address space.
So effectively today, you are going from something into IP, doing lookup on source IP to relabel, and then move into the other side.
And I agree. So that, from a network data plane perspective, doesn't look the most efficient. The hard
No, I'm just trying to figure out how it works.
Yeah, no, I apologize. The hard work in all of this hasn't been this. The hard work has been up here.
Of course.
Right. How do we get the management systems over here with their models to map? What Victor said, the key thing is this: that both sides have to be using the same model. Once that happens, which has now happened, the rest of the pieces we can move quickly on and improve the efficiencies and the implementation.
No, but once you get the hard part done, then you can scale the management plane to a gazillion users.
Yep, exactly.
And then that's where the hardware hits you. And that's why I'm asking about the hardware.
And then we move to the labels, and then the hardware scale grows massively. And now we're talking, if you have 500,000 users, or the Australian school system, 750,000, that's a big number. But if you look at the number of groups that they have, it consolidates down to hundreds or thousands. So all of a sudden, the label space becomes much more efficient. Sorry. And we're
just one clarification. During the authentication, the first label that you assigned there, yeah? Is this SGT or is this something different?
So
SGT.
Yeah, it's an SGT. So SGT, security group tag, originally was carried in the Cisco metadata header, the layer 2 header. What happened in both cases here, we took those 16 bits of that SGT and we embedded it in the RLOC location of the Lisp frame, VXLAN. And so now we carry the VNID, which is BD VERF, and the class ID, or SGT, different SGT sort of, it tends to bring back memories of old implementations. So we're saying class ID now to say the abstraction, or it's the same 16-bit field is now carried in the IP VXLAN header. So now you can carry it across IP networks. You don't have to have contiguous L2 with the L2 header carrying it across. So implementation is better, but the idea is exactly the same.
Okay, thanks.
All right, and then we're going to play tag team.
Okay. So one key thing that we were discussing there is, yes, we need mechanisms to preserve the semantics once things have been classified, but the key thing is you want to leverage the classification that has been done in each domain and keep that value. You don't want to lose that information. And that's what we're doing with that exchange, right? So key thing is, if I want to author policy, if you look at that diagram, it has a source and a destination. If I don't have both sides, I can't possibly author policy, right? So I ingest it on either side, exchange it, and now I can author policy in each domain. That's extremely powerful, right? It's sometimes taken as a given, and even if we have to map it to IP addresses, we have basically an environment where we can easily recreate the classification without having to have all the detail on how we arrived at that classification. That's the key thing. So even if I get a digest that is dynamically provided to me about IP addresses and groups, I'm getting it dynamically from the source of truth, which is basically where I'm doing the classification. So once I have that, right, from an access control perspective, I can do things like segment, right? So I can take a different set of groups and simply assign them to a particular virtual network. So by default, once I assign a group of endpoints to a virtual network, they will be isolated, unless I do something else in the network, they will be isolated from other groups that may exist in other virtual networks, right? So it's an easy way of doing coarse segmentation. We find many scenarios where people need coarse segmentation or what they call an air gap between resources, right? So for example, you have facilities, light bulbs, air conditioning, elevators, right? A lot of customers build a dedicated network for those purposes, right? And rather than having to maintain two separate networks, basically what we do is we are able to create a single network and create all these different virtual networks to satisfy those requirements, right? So that's a classic example on where you would use something like macro segmentation,
So effectively, you're replacing VLANs or VRFs with microsegmentation.
Well, no. We are supporting VRFs in the form of what we call virtual networks. And we name that macrosegmentation. Right? So when you hear macrosegmentation, we're referring basically to a virtual network in the form of a VRF, or it could be in the form of a VLAN. If your virtual network is one for labs, you are probably going to need some layer 2 connectivity. If you have a bunch of PLCs or some building automation that doesn't really work well in a layer 3 environment, then we can create a virtual network that is a layer 2 virtual network. Right?
So when you say microsegmentation, it really means VLAN or VRF. It doesn't mean echo on port.
Well, macro means VLANs
Okay.
and VRFs. Micro is referring to within that virtual network.
Okay, sorry.
Right? Within the container that has its own dedicated set of forwarding tables, within that you can then apply a bunch of ACLs, right? And I'm trivializing it, but there are group-based ACLs. So the key for the matching of the ACL is not going to be IP addresses, it's actually going to be the group tags. And therein is the value of the tagging, right? So again, in the same way as for authoring, I need the source and the destination, for enforcement, I need the source and the destination. Now, for us to scale this, right, and you hinted at this, but for us to scale this, you don't want to concentrate all the information about source and destination in one place. So if you think of how we connect to the network, right, at the very edges of the network, you have to maintain state for everything that is directly connected to you as a switch, right? As an access switch, if I have 1,000 endpoints connected to me, I keep state for those 1,000 endpoints, whether I like it or not. So it makes sense to keep track of those 1,000 endpoints and which groups they belong to. Now that gives me, if I'm going from those endpoints to a destination, that gives me the source grouping. So I tag any traffic that is going from those sources, I tag with the source group. And when I get to the destination, based on my IP address, that destination will be directly connected to all the destination endpoints. It makes sense to maintain the group to IP or port information at the destination. So now at the destination, if I had the tag on the packet and I'm arriving at a switch that has all the information about the groups for the destination, I have both sides of my equation and I can enforce policy. So that prevents us from having
Actually, what you're saying is you're avoiding the Cartesian product of source IP addresses times destination IP addresses in an extremely long echo.
Yeah, we're just avoiding Cartesian explosion.
So you want to have everything tag-based so that it is better scaling, yeah? So no IP addresses, nothing hard.
You see, traditionally you had 100 users here and 10 applications there, and this would be a 1,000-line echo.
Yeah.
Right.
Now you have one line echo saying users can talk to applications.
Exactly. So in order to get there, right, we have, as we were mentioning, we have a series of domains, right? We have access sites, we have our WAN, we have maybe another site that looks like an access site, and then finally we make it to our data center, right? So what we want to do is, if you think of the microsegments as labeled in red, I don't expect you to be able to read what's in there until you get the slides, which I presume will be handed to you. The macro segments are tagged with orange or yellow. I've been known to be very colorblind. What we're doing is basically we are preserving those semantics as we cut across the different domains. So regardless of what technology you're using in any domain, what you will find in the portfolio is that we've integrated basically all of these domains so that you preserve the segmentation semantics all the way from the very edge of the network as you cut across the WAN. And finally, once you get to your data centers, you want to basically hand them off. The simplest handoff today is basically to use a series of VLANs to represent the virtual networks, and then we use the CMD header, the Cisco metadata header is the least common denominator in the portfolio to carry the 16-bit tags, right? So we start there. That probably will evolve to something slightly different, but the key is we have a normalized handoff between the data center and the access network. And the key is to preserve this so that we can do the scalable enforcement of the policy based on what we described. Right? Keep that semantic so that we can enforce actively. Today, we basically do some reclassification in order to basically regain that red tag. Right? What we're saying is let's preserve the red tag so that we don't have to do that reclassification, so we get larger scale. Now, one of the things to notice here is that you have common borders between the WAN and the access network. So we put a lot of work in integrating basically the WAN and the access. And even though I have different controllers for the WAN and the access, I have integrated the way these controllers work. So if I want to create a virtual network that spans my entire access operation, I go, for example, to DNA Center and I create it once. And that will trigger all the API calls necessary for the SD-WAN to also have that virtual network. So I don't have to go touch many places. I can trigger basically the creation of that virtual network on one go. That information is also shared with ACI and APIC. Right? So either a shared service or a matching virtual network can be mapped to.
So just now we have the SD-WAN as an additional to that what we have before. And the end game would be to have, if I have SD-WAN controller, maybe my SD-Access controller and my ACI controller, to stitch them all together, yeah?
Well, to coordinate.
To coordinate, yeah.
Yes.
I just need somehow to make the tag exchange happening so that all controllers are aware of the tags.
Yes.
And then I can just, let's say, deploy ACLs based on these tags, yeah?
Exactly. Exactly. And we're closer than you may think, right? Even though these are two controllers, the workflows for the common tasks are unified in such a way that I basically go into one of the consoles and define a virtual network, and that goes out and makes any API calls that it needs to do to actually keep things in sync. So I don't need to go in DNA Center and then in vManage and create matching VNs so that this mapping can happen. I just create a VN once, and I specify which sites I want it to go to. Yep.
So coordination between the controller we are talking about, right? So SD-WAN transit we are saying. Let's say service is MPLS, and there is a MPLS VPN operator underlay. So in this case, this controller, will they talk with the, let's say, controller in the service provider network? Like right now, there is a draft, by the way, in IETF, how they talk through segment routing, etc. So what's your plan on that?
So think of the common services, right? If the common service is basically the creation of a VPN, and you have a service in the WAN that is basically managed by a controller, say you're using NSO, for example, to manage it, right? As long as you have the API calls in place to actually create a VN, you can actually go ahead and create the VN. Some of the integrations that have been done are actually a little more advanced than that. They actually go consult on that transit controller and ask about what is created already. And part of the workflow may involve asking the operator, do you want to map it to a pre-existing VN and reuse that? Or do you want me to create a new VN for you? So there are those subtle things that need to be put in place. But as long as we're integrating at the API level, you can appreciate how it actually makes sense to keep things separate because of these scenarios. Right.
And again, there's this particular view tends to be a little enterprise-centric for now. There is parallel work that's going on that's more directed towards 5GSP, which is, again, mapping of the pieces to an SR slice, right? Again, so this would probably not be SD-WAN in the 5G case. It could be, but in practice it's probably going to be something else. So there's parallel work that exists that does the same thing. If this VPN service here is SR slicing rather than essentially an SD-WAN VPN. So again, depending on, if you're an enterprise customer and you're not looking at building an SR backbone, what's your answer? If you are a service provider. So the model is the same. The technology we're showing in this case tends to be the enterprise one because that's just what we put on the slide.
That's a very good clarification, right? Yeah. So to answer your question properly, just swap this for whatever flavor of framing is being used in that service. Right? But the service remains the same. It's that orange segment. It's that orange slice.
Yeah, but the really tricky part here is who owns the namespace. Because if they have different namespaces, then you'll need all these translation tables at every boundary. Whereas if you manage to use one as the top controller that owns the namespace end to end, then your task will be way easier.
Yes. So that's where.
Or is DNA Center your leading device here?
For the integration with Vim.
Yeah.
So this is Victor's slide. On my slide, it looks the other way. But I think this, to answer the first question, architecturally, right? One of the things that we understand from an MPLS network is downstream label assignment, and that model of remapping allows you to do things. You consolidate. You take two networks that didn't have the same namespaces, and you put them together. Is that possible? It has to be possible, right? So if we build a model where it's a centralized authoritative namespace and it's not global like Aaron or Ripe or something. So at this point, we're doing downstream label assignment. That allows you to take this and this that may have been built independently without coordination and glue them together. Victor talked about there is a piece on top that actually has to say common identity, common policy, so each of you can do your rendering, and if you have to do a label swap because you're integrating two pre-existing things, you can do that. You may not want to do that if you've pre-built the labels, but you have to be able to.
In my case, let's say the controller at the customer side, the SD-WAN controller, and also we have now underlay transport, let's say MPLS VPN, each service provider probably has their other PC controller with competition element, and segment routing is running.
Right.
Currently, let's say customer wants, okay, in your network, lots of PE, P devices, lots of PAT you have, and some application traffic, I am looking for low latency PAT in your network. So controllers, basically they are interacting. Okay, this controller is asking from the top level controller, low latency PAT requirement, then top level controller is installing the segment routing stack for us. That's the whole idea, and there is no translation anyway here. It needs to happen.
Right. So that's
assuming a homogeneous environment.
Right, and that's a very interesting case because it actually talks to the importance of vertically integrating these solutions, right?
Exactly.
So there's a myriad of SD-WAN solutions out there, and they're absolutely divorced from anything that may be happening in that underlay. And what you just mentioned, what you just described, is a classic example of the value of actually having these things integrated.
Yes.
Right? And I can't emphasize enough that as we transit that WAN, as we go into the data center, even when we're in the access, that vertical integration of all the components for the purposes of providing a better service, but also for the purposes of getting better visibility,
as well,
it's critical. If I don't have control of the telemetry, if I don't have a telemetry footprint, I'm flying blind.
Of course. Maybe there is a failure and,
Right? So that's why I have controllers that are dedicated to this. I have controllers that are dedicated to this. I use different technologies in the different places because I have different problems. We're not just trying to make people's life hard. We're actually trying to solve your entire problem all the way down to where it matters. Because the thing that we do is we build networks in support of the application consumption, but we're building a network and we need to go all the way down to the bottom, but we also need to bring you all the way back up so we can actually fulfill the needs of those intent-based consumption groups, right? But thank you so much for that example because that exemplifies exactly why we worry so much about going deep and coming back up. It needs to be integrated as one stack. You mentioned two controllers. I would argue that if we do our job right, it's one controller that takes into consideration the entire stack. SR, the telemetry down at the bottom, all the way down to the abstraction of the overlay, coordinates them, makes sure one feeds off the other, and coordinates them.
Sure.
And we do that here, and we do that here, right? And you're pointing out we should be doing more here, and that is happening.
On the SD-WAN side, wider network side,
just as curiosity, you have another product in Cisco, which is Firepower, that also can understand SGT tags,
Yes.
Did you ever look into that also to to have the same kind of vertical integration?
Yes.
Yes, of course.
We've only got so many slides, right? But yeah, absolutely.
Okay.
We can go into that in detail if you want. Yeah.
Remember we showed an access domain, a data center domain, and a security domain. The firepower would be an example of that security domain with the same type of vertical integration philosophy.
Yeah, I missed a lot in the DNA center story, all the security firepower part. Yeah, so good that you have this also on your radar. Yeah.
Yeah, very, very much so. So again, vertically integrated, it's a must, right? The type of telemetry and visibility that we get by that vertical integration can't be paired if you just have an over-the-top solution. So we find a lot of, okay, I've solved your problem, I've made it simpler. If you have 20 minutes to look at things, it does seem simpler when you're talking about it. But then when you double click into it, you're like, well, you've only solved 10% of my problem, right? And you know, if you want a cake, you need to make a cake and then put frosting on it. If you just sell frosting,
There is always more. 1925 says, always more.
so other example of vertical integration. So you gave a fantastic example of the vertical integration, but another example is what we do for the integration of wired and wireless, right? So for the longest time, wireless was basically treated as a separate network. You had an over-the-top set of tunnels that went to a controller, and it had its own policies, it had its own language, it had all its own concerns. What we've done is we've basically brought the wireless network to basically drop the traffic at the access switches so that now, if you look at wireless traffic, it doesn't look any different from copper connected versus fiber connected or radio frequency connected. So I'm applying the same set of policies on the same set of user groups that I've created. I'm classifying everything the same way I would if it was wired connected, and I bring the enforcement points actually to my access layer. So now I've got a normalized view of any user that is connecting to this network. It gives me better scale, it gives me better mobility. I coordinate the wireless LAN controller with my control plane so that now all the reachability is handled by the control plane. Radio frequency is a specialized thing that the wireless LAN controller does better.
Says this control plane, so you have ITR, ETR, MRMS?
Yes.
Okay.
Yes. Yeah, and we can talk about Lisp exhaustively over a beer, but basically we brought these things together. Now it's really one system, right? No different from I have a controller for SR in my underlay, and I have a controller for my overlay, and how do I bring these things together? This is no different, right? So vertical integration, critical. Here's another example of vertical integration that Mike's going to share with you.
Right. Probably two topics here. The first one is simple vertical integration. So this is an architectural picture that comes from Google, right? From an enforcement perspective, when they look at it, they're basically saying the requirements are policy, what Victor and I are talking about, identity, and then the other piece that you guys are bringing up is, the real-time visibility of what's actually happening, right? So actually telemetry information, essentially munge that data and then drive a policy decision, right? Policy information point, policy enforcement points. General architecture makes sense, yeah? We will try and sell everybody a product that does that. That's what Tetration is, right? So I'm trying to do two things here. One of the pieces that Tetration I brought up earlier is the identity framework for applications we want to make process-based. We want to make it as granular as possible rather than just endpoint-based. So if we have identity at the process level, right, and we have enforcement points such as host firewalls and enforcement in the host, we also want to consolidate or coordinate that enforcement with this label enforcement that we're talking about and make them one common domain. So what we want to do is, and again, built, right? Kafka bus, and you're starting to see, you're asking questions about how do we get away from pairwise? The way we get away from pairwise, right, is to build a structured bus with, I can publish what I can do, I can subscribe what I need to do, and then each of the domains can implement, and we can feed back information about, did I do it, couldn't I do it, so that you now have a consolidated provisioning, dynamic service insertion, and more importantly, visibility about is it actually working end-to-end, right? So that piece down there, when we started talking about ACI, not shipping yet, but it's close because I can show you how it works. you can actually go in and say, if I want to have that policy repository that's in my, my Tetration model, which does all that stuff that we think is important, and I want to have the policy enforcement that it's doing in the host coordinated with the policy enforcement that's occurring in the network, which is in conjunction with all the traffic coming in from the SDA, SD-WAN fabrics, you can now go in and say, this tenant I would like to subscribe, which means that Tetration is actually creating the security group constructs. It's creating the policies, right? And it's using the same policy rules for the firewalls, host firewalls we'll start with, and the infrastructure. And so we're just smart enough to go, you can't just force people to do this, you have to let them bite it off in chunks, so it's fairly granular control per tenant. Do you want to make it manual or do you want to make it automatic, right? But the key premise is this sort of policy, complex policy engine can make sure the enforcement in the host and the enforcement in the infrastructure is consistent. PX Grid coming in, so you also have the identity framework common across both. Already work done to get AlgoSec and TUFN, so if you've got all the third-party firewalls, you now have a single point of a central policy control for your firewall, for your network, and for your host stuff, if you choose to do that. Right? So this vertical integration is not just about, it's about multi-vendor, but it's also about the granularity of the application fitting into the space with the user. Make sense?
Yeah, just a quick one. How do you enforce the host policies?
So Tetration as a tool has a mechanism to, and it'll actually, if you choose to do this, you install an agent on all the Windows and Linux servers.
Okay, over the Tetration agent.
Right, so the Tetration agent is then actually managing, it's doing multiple things. It's doing inventory, it's doing, it's actually looking as a security device for process escalation, signatures, all the event problem, but it's also managing the enforcement, IP sets, IP tables, Windows, all those things that are on the host. But then it's also saying, I want to do enforcement in the infrastructure because I want to prevent DOS attacks. I want to have dual, for all the various reasons. And now they're both coordinated, right? And you can see how this logically can extend, right, to more if we want to do that. But the key thing is vertical, right? This second thing that I wanted to mention is Andy was talking about, and just to remind you, Andy was talking about ACI Anywhere. Everything Victor said and everything we've said, we have a common identity space and a common policy configuration space now across public and private. This connects to campus and SD-WAN, right? So now we actually have that identity space common across all of the domains, and we have enforcement across all of the domains. So far, so good? Right. Yep.
Today, you have a one-to-one bidirectional link between a DNA center and a single APIC cluster.
You can do multiple APIC clusters, but each of them is configured today as a pairwise.
Yeah,
right.
Exactly. How does that leak up to MSO and then to AWS?
So from a pairwise configuration, and again, there's two parts, right? So the creation of the EPGs or the SGTs and the equivalent, today, we're doing pairwise. When this shifts to a Kafka bus, right, now when we have, this is the proposal, it's not shipped yet, but this is what's being built. So if DNA publishes a group, it goes here, here, right? So every consumer of that group structure, it's now rather than a pairwise implementation, it's a bus implementation.
But today,
yes.
With the pairwise implementation, whatever you do in the campus gets to the first APIC cluster and that's it.
Here, yes, but then in this picture, right, MSO then creates, because now that you have those EPGs, I'm not sure you've seen MSO, I would like this EPG to now exist and have a mirror image or an extension created in the other sites, the other fabrics. So everything that comes in here can be replicated over here. And then again, that group, and Andy sort of talked about all the mapping functions, so it comes across here, and as we go through the networks, and as it comes out, so the semantics of identity are maintained end to end.
And it's part of the objective to just establish a single peering with a system that may have multiple locations of multiple flavors. But I just want to simplify it and abstract it as, this is my data center. It's evolved from being just one location in a campus to basically becoming a multi-cloud, multi-geography, etc. But my problem is just, I need to peer with my data center, right? So, so you can appreciate how this abstracts it to that point, and I just have a single peering, single exchange, and then the data center takes care of replicating, copying, synchronizing, etc.
You want to federate blobs to begin with, rather than federating lots of little, because then...
Yeah, makes sense.
Okay.
Divide, conquer. And
yeah. So, and again, we're trying to give you guys a lot of information. Sorry, two things clicked at the same time. Victor talked at the very beginning about that provider-consumer piece, right? The edge in the graph between the two nodes. We tend to classically think of as access control, but it actually is much more than access control. It's the requirements for that user to that app, right? And what you see implemented mostly is access lists, because that's what most of, but what that's been built to whatever you need. And the simplest example that we're going to be available very soon is, you provide a set of services in a WAN administrator. I say, I give you 4 types of traffic patterns, voice, video, whatever you want to think of them. Ideally, what you want to have done is the consumer, right, or the application says, this application requires service level X. And I want to be able to sort of, in the same model that I essentially say, this user is allowed to consume this application or use it, I want to say when this user comes to this application, I want the transport requirements for that application traffic, which is really delivered by the backbone, to be met. So a single model to create the requirements of the app and a single place to effectively drive that intent-based configuration from in the same model. So functionally what you're really doing is inside this side, you have a representative of an external group, you have your internal group, and you're saying that the contract between that group and that group specifies permit, and by the way, it has the service policy required for all the traffic. APIC communicates with vManage, and any configuration changes required on the other side are done. So it's essentially cross-domain automation driven by policy. So in other words, if you add something here, you don't have to call you could manually go in here and configure IP access lists and do all of those things, but those dynamic updates, right? And again, when we move to labels end to end, the label, you just identify the label that's coming across identifies something. So the classifiers are the label mapping. But conceptually, because it's a simple idea, it's just extending that policy structure to drive cross-domain automation so that, from an ops task, you can say, I install an app and I want allow, permit, firewall, and I want this WAN service delivery for it. And if I install a new endpoint, a new VM, I don't have to call anyone because the automation takes care of anything that has to happen in the WAN transport to deliver that service for that endpoint, talking to that endpoint. Right. Marketing picture. The point is, and Victor talked about, it's not just it's a marketing picture, but it makes an important point. The edges that we're talking about are logical edges. In practice, they're distributed. Because if you have workload across Amazon East and West and multiple data centers, that person in the branch may be using that app and that app and that app, and the apps might be talking to each other. So these edges are geographically distributed. So that connection or that boundary exists wherever it needs to exist. But operationally, it looks like a single logical interface between the two domains, and the policy exchange and the mapping is identical across all those domains, because it really is 2 logical domains, even though there's lots of physical instantiations of it.
Yeah, it's basically a distributed way of delivering the policy enforcement, right? So if I have 20 locations, I've got 20 places where I have a coordinated view of policy to enforce.
Yeah. One red herring discussion, because I want to put it in, because this is, you guys wanted to know about ACI in this section. So we wanted to talk about ACI integration, but why the end-to-end architecture is important. And Victor talked about vertical integration. So the other piece that we think is important is, from an operational perspective, having the SLA delivery mechanisms that we have from a classical network construct. Actually, you have a set of people, application owners, looking at service level performance monitoring characteristics. Still bought AppDynamics, there's other competitors. But what we've done is we've done an integration vertically up the stack in a manner that says the application infrastructure, as known by AppD, is communicated to the application, to the infrastructure supporting that application, hence APIC. And really, in practice, what we get is you get NOC views of the network driven by the AppDynamics. So AppDynamics says I have an application on these endpoints, and the two systems are essentially exchanging information. So the NOC has a view of that JVM on that endpoint in that security group. So when they're trying to when they get a call from the application team talking about response problems, their process to understand where something's running isn't give me an IP address and give me this stuff. It says, I have a map of your app, and I know that that JVM is running on that endpoint, and I know that endpoint is here, and therefore you can start to correlate and troubleshoot. The corresponding view is the information is also coming up to AppDynamics, and so if there's any network faults, performance information, problems, all the things that we're doing, the performance tools, they now include that information in their analysis of, is this app working and why is it not working? So we're doing exchange of information this way. Different personas, it's the same application on the same infrastructure, and the goal is to create user to app and visit application to infrastructure and have all those mappings occur in a coordinated fashion. So it's one policy domain, one identity domain, one operational domain. Which gets us back to the sort of the beginning point. We talk about that app connection. The specialization with the domains exists, so the vertical integration exists because the pieces that matter here from application performance were perfect, and workload management and everything else are very different from wireless management and all of the IoT components here, which are very different than this costs me a lot of money to add bandwidth here, so I need to micromanage it or manage it in a much more granular fashion. But the goal is, it's a user to an app, and we want to see integration this way, which is what we've been talking about from a policy perspective. I want to see integration this way, which is also policy. I want to know that my policy is actually being implemented and is delivering the service that it was designed to do. Conceptually, yeah. We got 5 minutes left, so we want to sort of leave the floor open for some questions. So we sort of, right? And someone created the slide, so I thought it was funny, right? It's been a secret, and yes, it's possible, right?
Yeah, I think what is challenging, you have a lot of moving parts, yeah? When I look on the components that you are using, yeah, and don't get me wrong, I like that you're looking for the vertical integration, yeah, but of course the testing is maybe quite difficult, yeah, if you have so many components that are involved, yeah.
And yes and no. And one of the reasons, and Victor will correct me, one of the reasons we've been building domains like this, is you can think of more like Duplo. The integration and the details of implementation and function within the domains can be tested. And then the interfaces between the domains that are abstracted, and you can just test a much simpler set of interfaces. So the end-to-end problem is effectively decomposed. If we were to build one controller to do all of this, you'd never get it. You'd never end up through QA, and everyone would be happy. But if we can engineer the solution into optimized components, test and validate in those optimized spaces, and then aggregate, it's a classical engineering problem. In each of these spaces as well, you're going to have aggregation, right? Of, this is tested, connected to this. But if we do that, then we're fairly confident that we can deliver this, because we actually have, everything we've shown you is working. Half of it's in production. The other parts will be in production by summer or later this year.
I can also imagine the kind of how we worked in the past. Maybe we had a WAN team, we had a data center team, and so on. So now somebody who's troubleshooting this, yeah, would be more an end-to-end perspective on that one, yeah.
Yes. So there's that advantage, but the different tribes have been factored in. So you have access to the system as an individual within your realm, and you have control of your services. They have control of their services. They have control of their services. In a more evolved IT organization where there is some commonality and sharing of chores, you can access the system at a higher level, right? So that transition has been factored in. The other thing that we've done is the NNIs between these domains. Where practical, we've simmered that down to basically single boxes where there's really very little that needs to be done outside of what the OS is actually doing for you, right? So the integration has been tightened up as much as practically possible for the scenarios where you have basically legacy WAN services, etc. Yes, integration is a little looser, but even that has been streamlined to, we normalize it to the least common denominator. Right? So,
sure, I'm a fan of that, yeah. So, but I think the approach where somebody worked in silos, this will maybe fade away with that when the tech is more on end-to-end, even with this single entities that are still operating independently, yeah?
Yeah.
So I think at the end of the day, it's an end-to-end connectivity, yeah?
yes, yes, that's the key.
That's what matters
Yeah.
at the end of the day. Right? So you need, that's what the telemetry needs to correlate to, that's what provisioning needs to coordinate to, that's what security needs to coordinate to. So again, just to summarize, we built interfaces and I ran through it. Right now, we're publishing and saying this is what you can do, this is what I'm allowing you to do, and you can pick and choose, right? Over time, we publish those things still within this individual domains of control into that box that Victor had on slide 3, I think. And so these are the functions I'm allowing to be provided by the end-to-end service. And so then the orchestration that exists up here, or the policy configuration, you can't override and say this domain does this. The domain publishes what it is willing to do. Money's involved in these decisions. Money's involved in these decisions. Risk and money are involved in these decisions. Right? So these domain owners manage that, and then they say, based on those decisions, I allow this, glue it.
And I think the centralized approach makes absolutely sense, just compared with something that has failed brutally, cross implementations, yeah, where everybody had a slightly different approach, yeah. So I think it must be centralized, and it cannot be overwritten. It comes, and everybody has kind of the same knowledge and using the same tags. Yeah.
You know, how do you have multiple scopes or zones of control that are actually, you know, resolved before you push flattened requests down to the other side? That's the key thing that we have to do up here. You know, Victor and I hate each other. We don't. But if we did, we should still be able to run an infrastructure. Right? And, you know, he says no, I say yes. There's a resolution because the InfoSec says yes. So therefore, InfoSec wins. So that hierarchy of, you know, that has that policy tooling has to accommodate all of that. And
yeah, and the value of the digital tools, the digitization of the information exchange is huge, right? Rather than me having to go and, hey, Mike, what is it that we agreed on, or what are your groups, etc. It's like, no, they're there. And, oh, Mike created a new group. Did I get InfoSec to tell me, well, is that group accessible or not, right? So that's huge. I mean, the time savings and the digitization of that process is...
Yeah, just to close it, you said you had this already running. Sounded for me like a little bit, it's inside of Cisco. When is this somehow published and available for customers? Do we have any kind of timeline?
So this integration between this and this, I thought was supposed to be, I mean, we've been telling people about it. It's supported, you go to CCO and you see it documented. It's not been advertised. That's a problem. The integration between here and here has not shipped yet. It'll be shipping from the 4.1 release of ACI, which is coming out. But again, I think they want to defer the public launch of it to San Diego, Cisco Live. You know,
for the SLA integration.
Yes, Cisco loves to bucketize stuff and make big noise, right? So you're actually going to have code before you have announcement, right? We're telling you because this is, you know, classically you get sold bits and pieces. Even though we've been building them to work together. So
also the integration between the SD access and the SD-WAN, single box with the API calls, etc. That's actually being announced here at the conference.